Hi, good morning. In this PPT, we are going to take a seminar on atomic battery. Introduction. What is atomic battery? The term nuclear battery describes the device which uses the energy from the decay of the radioisotope to generate electricity. Like nuclear reactors, they generate electricity from the atomic energy, but differ in that they do not use a chain reaction, also known as atomic battery, tritium battery, and radioisotope generator. Next, we will say evolution of the atomic battery. Nuclear battery technology began in 1913 when Henry Moseley first demonstrated the beta cell. The field received considerable in-depth research attention for applications requiring long-life power sources for space needs during 1950 and 1960. In 1954, RCA, which is termed as a Radio Corporation of America, researched a small atomic battery for small radio receivers and hearing aids. This is the schematic representation of the first resonant nuclear battery, which was developed by the Paul Brown. In this radioisotope source of alpha and beta radiations placed inside the resonant tunes called as a circuit, which produce electricity with the help of radio isotope source with the help of decay process. Next, we will see the classification of the radioisotope generators. Radioisotope is classified into two types: non-thermal converters and thermal converters. Non-thermal converters is further classified into direct charge batteries, direct conversion batteries, indirect conversion batteries. The direct charge batteries is further classified into alpha, beta, p-n junction, contact potential, and secondary electrons. Next, you will see the conversion techniques. The conversion techniques can be grouped into two types. First one, thermal, whose power output is the function of a temperature differential. The next is non-thermal, whose power output is not a function of difference. The first is thermal converters is classified in consists of many types, namely therm converter, radioisotope thermoelectric generator, thermophotovoltaic cells, alkali metal thermal to electric converter, Stirling radioisotope generator. First, we'll see the thermo-ionic converter. A thermo-ionic converter consists of a hot electrode which is thermo-ionically emits electrons over a space charge barrier to the cooler electrode, producing a useful power output. Cesium vapor is used to optimize the electrode work functions and provide a ionic supply with the help of surface ionization to neutralize the electron space charge. The next will be a radio isotope thermoelectric generator. A thermoelectric converts the thermocouples. Each thermocouple is formed from two wires of the different metals or other materials. A temperature gradient along the length of each wire produces a voltage gradient from one end of the wire to the another. The next is thermophotovoltaic cells. Thermophotovoltaic cells work by the same principles as a photovoltaic cell, except that they convert infrared light emitted by a hot surface into electricity. Thermophotovoltaic cells have efficiency slightly higher than the thermoelectric couples and can be overlaid on thermoelectric couples, potentially doubling efficiency. The next is alkali metal thermal to electric converter. The alkali metal thermal to electric converter is the electrochemical system which is based on the electrolyte used in the sodium sulfur battery. sodium beta aluminum. Efficiency of AMTC cells have reached 60% in the laboratory and is predicted to approach 20%. Stirling radioisotope generator. A Stirling engine driven by the temperature difference produced by radioisotope. New developments will lead to the creation of the more efficient vessels known as advanced Stirling radioisotope generator. Thank you. In next PPT, we will detail about the other types of the atomic battery.